My name's Anna Kladzyk. I am a graduate student at the University of Texas at Austin in the Water Resources Engineering Department. The workshop is called EarthWork, Interpreting Landscape Signatures. It's a kind of an extension of my research in that we're using open source GIS softwares to calculate different parameters on the LiDAR data and then using statistics to plot those parameters to identify certain important features in the data in order to derive the channels and derive the channel heads, or the most upstream points of the channels. The first day we did an introduction into what GIS is, it's Geographic Information Systems, kind of the basics of what you need to know in order to use it properly so you're not making errors that have to do with how you're projecting 3D space into 2D space, because you have to have some prior knowledge in order to do these analysis so that it's not incorrect. So day one was focused on learning about that, and then in the afternoon we experimented with the program and we downloaded the data and we started playing around with it in GIS and learning how to use the software. The second day we focused on anthropogenic influence on landscape processes. That's a huge topic, of course, but we focused specifically on dams because that influences hydrology and geomorphology. In the afternoon we went to a dam, La Presa Esperanza, and got to see firsthand how downstream looked very different than upstream of the dam. So that was pretty fun, and we kind of touched on more ecological impacts of anthropogenic influence, so talking about how dams can prevent migratory fish from swimming upstream, how dams can change nutrient supply into waterways so that you may have algae blooms or other nutrient impacts that affect different species in the water. Day three was our really software-heavy day, so we did some calculations of our data in GIS. We calculated the slope of the landscape and the flow accumulation area, so that's all of the area that's draining to a certain pixel. And those two parameters are really important in this type of analysis because you can use a plot of those to find an inflection point that gives you a threshold area that we use as the minimum in this channel extraction program to find the channel heads. So we calculated these parameters in QGIS, and then we exported that data and plotted it in MATLAB and found these inflection points, and then we used that parameter to run our GeoNet algorithm and found the channel head locations for this area. On Thursday, we went to La Bufa, which is this very high rock outcrop on the top of a mountain. We hiked up there and we looked at channel heads in that area and some channels that were formed from runoff, flooding, moving kind of road sediment, and had some discussions about sediment supply and supply limited versus transport limited hill slopes. And today we have been trying to consolidate all these ideas. So I'm hoping the students gain some confidence with using these softwares and can use them again in the future. Also, I hope they have an appreciation for different physical processes that impact how landscapes form. The students are all very engaged and very excited to be there. I mean, I hope they learned something from me, but I definitely have learned something from all of the students. You know, this network of kind of young scientists, it's really exciting to be a part of meeting other people from University of Guanajuato. When I was in Ensenada, meeting people there. I think it's a great opportunity to meet many different people that are studying many different things. You think you want to be this one thing, right? But if you learn more about it, there's this whole nother world of wide world of science.